We're going to take a few minutes to review all of the problems from the stations that you did earlier this week. So this is one of the ones that you had for your Notice and Wonder station. And I had asked you to just write down all the things that you noticed and all the things that you wonder. And a lot of students, by the time they wrote down all of those things, they found that they were also finding all these missing numbers. And you'll see that this one has a whole bunch of them. The next one that we look at doesn't have quite as many missing numbers, but these two parallelograms did. So the first thing that a lot of you did, and I encouraged you to do, was to find the corresponding sides. And that's always difficult when the shapes are rotated. So if I were to take this side here, which is the short side of my parallelogram, I can see that that's the same side corresponds to this side over here. Okay, so that's the first thing I would look at. And then I can take a look at some of the other ones, and I notice that this side would be corresponding with this side here. So that will help me as I'm starting to look at my missing numbers and try to figure it out. So the first thing I did was I looked at the angle measures, as I see that I only have 2 of them labeled. So I had to think about everything that I knew about transversals and parallelograms that we learned about in the last unit. So if I think about this, I know that a parallelogram has to have 4 angles that are going to equal 360 degrees, because we are talking about a quadrilateral. And I also know that the opposite angles have to be equivalent. They have to be the same number. So if this angle here is 68 degrees, well, I know the same thing is going to be here. And since we're talking similar figures, the angles, it doesn't matter what happens to the side lengths, the angles stay the same. So if I'm looking at my largest shape, 68 and 68. So in order for me to figure out which number is going to go for these last angles, I have to take 68 and 68 away from 360 degrees. So if I do 360 minus 68 minus 68, I know that the last 2 have to be 224, and I know that they're equivalent, so I can split it in 2, and I get 112. So I know that all these other 4 angles, they would be 112. Okay, so I can start there with my angles. The next thing I have to look at, though, is this missing side length. And for this example, I'm going to look at the ratios. So I'm going to look at the ratios of these adjacent sides, and I'm going to look at the short to long side. So I'm going to actually set myself up a ratio table, and I'm going to put my short side on the top, and I'm going to put the long side on the bottom. So if I look at my smaller shape, I see that the short side is 12.5 and the long side is 18.75. And then I'm going to look at my larger one, and I see that my short side is 27.5 and my long side is the one that's actually missing. So now I have to figure out, well, how am I going from one number to the next? How do I go from 12.5 to 27.5? Because whatever I do there is going to be the same thing here. And the numbers aren't always going to be really easy to figure out. So we can always go back and we can do our division. So in order to figure out what number to multiply by, I can easily just turn that into 27.5 divided by 12.5. And that gives me my scale factor of 2.2. So in order to make these equivalent, I then have to take my long side, 18.75, and multiply it by 2.2. And my missing side length would then be 41.25. So I can use those ratios of adjacent sides. For this example, I'm going to instead use scale factor. So remember, by definition again, scale factor is the number you multiply any side length by to get to the new one. So I see that I'm trying to go from 8 to 14. And again, I can do the division. So 14 divided by 8 gives me 1.75. So I know that my scale factor is going to be 1.75. And I can double check all of these other side lengths to see if my number is in fact correct. So I can do 5 times 1.75, and sure enough, I do get the 8.75. So I know I can use that to find this missing one here. So if I do 4 times 1.75, I will find that my missing length here is 7. There's one more missing side here, and you'll notice that it's going backwards. So I need to do the inverse, the opposite, and instead of multiplying this time, I'm going to divide by 1.75, and 1.175 divided by itself is going to give me 1, which is my other missing side. I don't have to check my angles here because in this shape they are all right angles, so I know that the angles are not changing from one to the other.